Brilliant. So thanks a lot, Robert, for the introduction. So just a quick intro of me. My name is Abdi. I work as a solutions engineer at Grafana Labs, based out of Stockholm in Sweden. So I'll take this in English. Do you understand Swedish, Norwegians? You do?
Usually do.
Yeah, but let's do it in English. Yeah, I have a very hard time understanding Norwegian. It's like 50%, some words here, but I think let's keep it simple and let's do it in English. But I think what we're going to do for the next 25 minutes-ish is just a quick introduction to OpenTelemetry, to tracing. We'll just do a quick slides, and then I'll actually walk through a demo of how tracing looks, how we can configure OpenTelemetry, and then actually see it in action. But before I start off, who's actually not familiar, but who's actually set up and used OpenTelemetry? Just a show of hands. All right, I think the majority have added. Who hasn't? Just a show of hands. Who's completely new to it? But I know you're not. But all right, I think you're gonna hopefully learn some new things. But I think the official definition of what OpenTelemetry is, according to their website, is a vendor-agnostic way to process, to receive, process, and to export data. So you can kind of see it as an ETL process, if you worked with data warehousing, extract, transform, load, but for observability data. And what we're trying to get away from is the classical agent-based monitoring, where you install an agent on a host, on an application, and that agent only works with some proprietary backend. I'm not going to name any names, but getting away from that kind of agent vendor locked-in approach. So this is much more open, and as we saw on Robert's slides, a lot of different observability vendors support OpenTelemetry now. So Grafana Labs being one of them. You got Elastic, Datadog. There's a lot of different vendors out there. So no agent needed, just to use and set up OTel, and you can export all of the data to whatever backend or whatever observability system that you might be using. And when it comes to the architecture of how OTel looks, as I explained, you got kind of the extract, transform, and load approach. So you first have the receivers. So how we actually going to receive the data. So we have a lot of different receivers that we're going to see, but metrics receivers, log receivers, and receiving actual traces. And in the middle, you have optionally, you don't have to do processing, but you have a way to actually route the data, scrub it, clean it. Yeah, there's a lot of different ones. If you actually want to do stuff on the data before, as we can see on the end, exporting the data to whatever destination that you might want to export the data to. And here we can see a list of some example receivers. So there's receivers for databases. We got Kafka. There's Azure Monitor receivers, AWS CloudWatch. Processing wise, we can see a lot of them as well in the middle. And then when it comes to the exporters, there's a wide range of them as well. So that's kind of the high level architecture and overview of how OTel looks. And how do you install it? You can install it as a kind of single binary, run it on your local workstation, laptop, just to give it a try. And there's also a Kubernetes operator for OpenTelemetry if you want to run it actually at scale. And there's two versions of OpenTelemetry. And this is good to know. You have a core version, which has a very slimmed down list. Just unmuted. Nice. Very slimmed down version. It doesn't have all of these kind of processors and exporter. There's some missing, but in the contrib version, that pretty much has everything, right? So that's kind of the difference. The core is just a very simple one, not everything in it. The contrib one has basically all the receivers, all the exporters that you might need. And just some configuration examples, just set up some simple ones here. So this is one for receiving and exporting some metrics. So this is how the configuration of OTel looks. We have receivers. Optionally, we can put in some processors, but I just excluded it here. And what I'm receiving is some Prometheus metrics. So I'm scraping some job from a server here, or some app metrics. And after I've received them, you can see the scrape interval is 15 seconds. I'm exporting that to a Prometheus endpoint. So that can be Grafana's Prometheus endpoint. We have a cloud version. You can send it to Elastic, whatever type of exporter that you might want to use. Very simple, right? And once we've done that, in this example, I'm just looking at the Grafana dashboard. All of my metrics have been ingested, and I'm querying them and looking at them in a dashboard. And for logs, similar approach. In this example, I have a log receiver, so I'm actually scraping a log file, as you can see at the top, so a test log file. I'm processing and adding some attributes. This is, again, optional if you want to do that. And after that, I'm actually exporting the logs to Grafana Loki, which is Grafana's logging backend, but you can, again, export it to whatever you want. And down, you can see the actual pipeline. So I'm receiving the data, processing and adding some attributes. And at the bottom, I hope you can see there at the back. And then at the bottom, I'm actually exporting the data to Grafana Loki. And again, once I've done that, being able to query them, create dashboards with my log data, and So that was on OpenTelemetry. So before we actually go into tracing, let me just see and show you some example live demo examples. So this is an OTel config where I'm actually taking some logs and some data that I have in AWS CloudWatch. And I want to send that to Grafana Loki, which is Grafana's backend. And again, if we take a look at the config, very similar, but in this case, I'm using a AWS CloudWatch receiver, right? There's a lot of them. And you can see the config. I'm scraping taking the EU North, which is where my host is. I've removed all of the credentials and everything else that might be needed. I'm polling it at a 1 minute interval, and you can see the streams that I want to extract, which is my Nginx logs, right? And processing wise, I am adding a routing processor where I'm routing the data to 2 different Loki destinations based on the attribute in the logs, right? So so I have an attribute called region, and if that attribute is US, I am exporting it to my Loki US instance. And if it's EU, I am routing it to my EU instance, right? So just an example of how a processor might look in OTel. And down here, you can see my actual exporters. And I've just removed the usernames and the passwords and things like that. And then the pipeline here at the bottom. Pretty straightforward, right? And once I've done that, this is my Grafana example where I'm ingesting the data and looking at them in Grafana Loki. But here we can see my raw logs coming in. They're all in pretty JSON format. And Grafana Loki has a very neat JSON parser. So we automatically extract all of the metadata in the logs as specific fields, as we can see. So all of these are just JSON fields. And using those JSON fields, I can create Grafana panels, right? So just taking the total request, for example, or taking the region, which is also a field in my log file, and creating a geomap to see where my traffic is coming from. So basically just visualizing the data that I have in the logs in a more prettier format. Sweet. Any questions on OTel? And when you say any questions, no one asks a question. Yeah, shoot.
This is just logging, right?
This example was just logging, but for you can use it for metrics, traces, or logs.
How would you connect the log lines to traces and metrics in this example?
Good question. I have an example at the end, but for logs, typically we would use a trace ID. So if the log is emitting a trace ID in the log, we would use that to create a drill down link, for example, in Grafana to link it then to the trace. I think there was someone else. No. So that was on OpenTelemetry. So I think the next 10-15 minutes-ish, let's focus a little bit on the tracing piece. Again, a question: who's actually set up distributed tracing here? Show of hands. In production? All right, quite a few. So tracing, I think, is the new player it's not really 3 pillars. We have 4 pillars, as you said, right? Yeah. So you got metrics, tracing, logs, but you also have profiling, which is the new 4th pillar of observability. But tracing, as Robert was mentioning, is going to help us understand where an issue might be, right? Log and metrics might be enough, but in some cases, traces can really reduce that troubleshooting time. And why do we need tracing? I think you're fine with metrics and logs if you have a very small, non-complicated environment, but modern environments are very complex. You got a lot of microservices, you have a lot of dependencies, and just using logs or metrics to troubleshoot can be very, very difficult. That's why metrics or tracing can help us pinpoint if it's a database issue out of the 100 microservices that you might have, if it's microservice C or if it's dependency B or whatever it might be. So really drill down and find where the issue might be. And this is just a very simple example, but let's say you did not have tracing, and this is your e-commerce application, let's say, and the user just complains that it's slow to log in, right? So where would you actually start? Is it the database that's having a problem? Is it the processing service, API service? Is it some kind of payment provider that you might be using? Where is the issue, right? And what tracing can help us do is to show exactly, first of all, how long it takes from point A to point B, but also how long the microservice, the individual microservice takes to process that specific transaction, right? So if there's a problem, we can quickly see that, oh, it took 5 seconds to run a SQL statement on the database. That is the issue. And it's not the front end, or it's not the network, or whatever people blame. And how would you actually set up tracing? OpenTelemetry has a lot of different SDKs. I think there's an SDK for pretty much any programming language out there. Most of them has what you call automatic instrumentation, which means that you do not need to change the code or anything like that. You just add an SDK, and it automatically does the instrumentation for you, right? And you don't need to have a pipeline. That's why it says optional. You can just take the traces and send it directly to a backend. But you have OTel in the middle as a collector to kind of just batch it, clean up your data, sample, and things like that. After you've done that, you have backends, Grafana Tempo being one of them. But you have, I think in your slide, you had Jaeger. There's a lot of different tracing backends out there. Well, Grafana Tempo is one of Grafana's own tracing backends. And after that, typically you have some form of visualization to look at your traces, your trees, and kind of just visualize the data that you're ingesting. So that's how traces are flowed and how the architecture looks. But let's go ahead and look at a real life demo example. So if you go into OpenTelemetry's website, you can see, there's a lot of different things in here, but you can see what I just spoke about. There's a lot of different SDKs. So we support C++, Python, Java, Ruby, Python, whatever you, go ahead.
Oh, sorry. When you say Tempo is the backend, what does that mean? Is it a database for storing stuff?
The traces, yeah.
It's,
just repeat the question?
Yeah. The question was, what is Tempo? Is it the database to actually store the trace data? And then...
So my question is more, does the OpenTelemetry standard, does it also standardize the backend so that Loki is an implementation of a standard? Or like, where does it end being standardized?
Not sure I get the question.
So yes, more or less. So tracing is handled the same way, logging is handled the same way, and metrics are handled in the same way, and then it kind of converts it into the different backends and whatever it requires on that end. So if you implement OpenTelemetry, that means it will handle these things the same way, but then it can store in different places. And then obviously there are some standards when it comes to how you do logging, how you do et cetera, that.
The format that you save it in the database, that's not part of the protocol or the standard.
Yeah.
Or the query language.
No.
Or the query language.
Yeah.
Thank you.
I think you answered the question. But yeah, it's too short. It is the backend, and if you use exporters in OpenTelemetry, there's an OpenTelemetry exporter, right? And that is what we use to send the data to any OpenTelemetry compatible tracing backend. Tempo being one of them, to store traces, Jaeger, there's a lot of them out there. But yeah, a lot of different programming languages in there. As I mentioned, you have two options. You have the automatic instrumentation and you have the manual instrumentation, right? And there's pros and cons to both of them, but most of the cases, you can just install the SDK and the automatic instrumentation works just fine. And to show you an example of that in my little demo app, if I zoom in a little bit, it's just a very simple Spring Boot application. And what I've done in this example is I'm just downloading and attaching the OpenTelemetry Java agent, right? And this, if I just attach this to my jar and if I run this together with my application, it's gonna take care of all of the tracing, the propagation, everything that OpenTelemetry does, or what tracing does is just gonna do it for me. I just attach that SDK and voila, it should just work. Second thing that I need to do, and to kind of circle back to the question over there, is that I need to tell the application where I've attached this SDK, where it should export the traces, right? And in this case, I'm exporting it to my OTel collector. It can be directly, as I mentioned, to the tracing backend, but in this case, I'm sending it to my OpenTelemetry collector to do some processing on the data and then further send it to the actual tracing backend. And this is how my OTel config looks. So I have a receiver actually receiving the actual traces over OpenTelemetry. And after I've done that, I'm exporting it to my tracing backend. That's all I'm doing. And optionally, you can add what we call span metrics, which means that it's automatically going to generate and extract metrics from your traces. And this can be good if you want to, for example, see in a metric, see the response time per service, or see the failure rate per specific service that you might have, or whatever it might be. You can do that automatically using this connector, so you don't have to create your own metrics manually. And then I have my specific pipeline here, the OTLP, and then actually exporting it to OpenTelemetry. And if you want to have a more visual representation of how the pipeline looks, this is how it looks. So receiving the traces, batching it, generating the metrics, and then sending it to my OTLP backend.
My apologies.
No worries.
Those traces are sample-based, right? While metrics are more statistics-based. So with the span metrics, do that happen before or after the sampling?
If you sample your traces, the metrics are also going to be sampled. So that's something to keep in mind. If you do not want them to be sampled, you might as well just generate them manually. So that's, yeah, good point. And this is a dashboard that yeah, go ahead.
You don't have to sample the traces.
It is optional, yeah.
Everything.
That is true, but
We sample everything. We don't sample at all. We ingest everything.
Same at Nav as well.
But they can afford it as well. Right? Think about that. It is a lot of storage.
Nav has a bigger budget than us.
Yeah, but yeah.
Yes, that's interesting. So my apologies for interrupting.
No worries, no worries. Good question. All right, so we've ingested the traces. We're processing and sending it to OpenTelemetry, to Grafana's backend. So how do we actually visualize the traces? In this example, there's a lot of dashboards in Grafana if you haven't seen it. And there's one called OpenTelemetry APM, and this is a templated dashboard. And what this one does is that it can visualize mostly the metrics that we're receiving from the traces, right? So you remember I was generating some metrics, and using those metrics, it can visualize it in a dashboard like this. So these are all data based on the traces that we're sending in. So the latency, the request rates, errors, all those kind of things. And here I have it as an example running in my little demo application. And I have a Spring Boot app, And yeah, we can see the different type of data in here. So this is all traced, kind of based on tracing data. So this is the metrics, and also if you have an environment that's distributed and you've instrumented it with tracing, you also get an automatic service map in Grafana. And this is what I was talking about earlier. This is also automatically generated, but to see the flow of your application, your different microservices, and also when there is an issue, again, you will be able to pinpoint where the problem is. So in this case, the entry point for our application, this example, is the front end. And we can see all of the different services it's communicating with. Speaking to some card service. And if I zoom in, we should be also able to see the latency between each service. So we can see the requests, the traffic, but also the latency. And if there's a high amount of errors, it's going to change the colors, as we can see here. So this automatically generated if you've instrumented tracing on all of your different microservices. And if you drill down into a specific service, if you just take the checkout or the payment or something that was having problem in that big map, you will get a list of all individual traces. And this is where you can dig in and actually analyze specific traces. So if something went wrong, or if there's something that's slow, and if you want to kind of drill down into a specific trace or transaction, you can do that. And here is one example where I'm looking at one individual trace, and I can see the entire kind of tree of requests. So where does the actual request start? In this case, it's starting at this requester, and then we can see everything that it's doing after that. So it's going to some endpoint, it's doing a JSON parser, and it's doing a select query against the database. And this seems to be the slowest because we can see that majority of the time is spent on actually doing the database statement. And if we want to drill down and actually see what's going on, we can open this up and see the exact connection string, but also the exact database statement. So it kind of helps us identify, that this query is having some latency and giving our end users maybe some potential slowness and problems. But yeah, that was, I think, right on time, right? How much do we have left?
I think we're right on time. If there are any questions, we have time for that as well.
So that was all that I wanted to show, just a quick intro to OTel and also how tracing works. So yeah, hope that was helpful.
Question about passwords. How do you ensure that they are not in the logs or some GDPR problems or things like that?
So typically what we
Can you repeat the question?
Yeah, the question was how do you mask or how do you make sure that the sensitive data passwords are not in logs, right? So typically what we recommend is to do that on the I don't want to use the word agent, but do it on the collector side. And OpenTelemetry itself has some processors to do redactions and maskings and kind of things like that. But you should take care of that before actually sending in the data.
And when the accident has happened, you have some passwords, something in your logs. Of course, you change the password, but do you have some way to delete it in Loki in the trace storage?
For trace storage, I'm not sure. We can always do it kind of manually, but for Loki, there is a specific API to delete log entries. I know that's for sure.
Not on trace.
Trace, I'm not sure. Maybe you'll have to go into the bucket and then delete it manually yourself. I don't think there's an API for it. Stopped working?
It lights up.
Was there? Yeah.
Right. So following up the question from earlier, the cost of tracing. So since Nav is sampling everything, that gives me the impression that the cost might be lower than I think. Could you say something about that?
Is this mic working? Isn't, right?
No, it lights up here, but
I'll bring it back and then I'll change the batteries on that.
Quickly. Yeah. Maybe you can you tell us, I'm not sure if you mentioned sort of where is this data in Tempo actually stored?
Exactly. So the reason why Tempo is cost efficient and why typically we don't need to sample the data is because the the storage is actually on object storage. So any form of like S3 compatible storage, like blob storage or MinIO, if you're running it on premise, is where you store your traces. So that is what makes it, relatively cheap.
And same for Loki as well.
All the backends, Loki, Mimir, Tempo, all the Grafana's backend are based on object storage.
But for the agent collecting the data, it samples a lot of stuff, so it changes your running program. Does that have an implication?
It's not the instrumentation SDK that's doing the sampling, is the collector, the OpenTelemetry one in the middle. So if we go back to where did we have this one? Here. So it's the pipeline where you do your kind of sampling, but you don't have to do that. And as we heard, these guys are not doing that either.
So the application will have the performance implication of sampling everything.
It's just collecting everything.
Everything.
Yeah.
Yeah, right. So it's just the cost of transferring and storing the data.
And because this is a very hot and interesting topic, I believe sort of, or at least from Nav's perspective, we believe that this is sort of like on a hyperscaler scale, you definitely need sampling, no doubts. But to this point, we haven't seen the sort of the cost and the performance, utilization, etc., hasn't sort of gone to that level where we need to do that. You have some very advanced sampling options in the OpenTelemetry collector, because you can do sort of like tail-based sampling, and there's white papers written about this stuff, where you can actually because the problem with sampling is sort of like if you have this one-off event, you would really like to catch that, because that's the really interesting stuff, not all of the other stuff. And if you're sampling like depending on your sample rate, that's the chance of catching that one-off event. So what you can do is sort of the tail-based sampling, and that is why sort of sampling is best done at the collector stage. You can of course configure each application to do sampling, but you would really like to do that on the pipeline, as it's mentioned here in Abdi's slide here, because then you can actually see that, okay, I can buffer up all the spans that are called in OpenTelemetry, and then I can look at them and see if any of them had an error, because that's a part of the specification. And then if that is set, I can then make a decision and say that I want to keep this. So that's sort of but of course that has some other challenges. You need to buffering and so forth. So it's not sort of what if you need to set some timeouts for when you're actually going to make a decision, because you might never know when a trace is done. If it's asynchronous, it can be never, or it can be in 1 hour or 10 seconds or milliseconds. Sort of you really don't know, so you need to set those. And that again, sort of like these decisions here have some trade-offs. So I wouldn't go running into sampling sort of as a start. It's rather something that you would do when called for. It's also I have not looked at this myself, but do you have this protocol also to more dynamically configure your agents, so you can say that for some reason I would like, normally we are doing sampling, but for this instance now we really want to get everything. So the application is always sending, and then you can dynamically reconfigure the agent to say that for this application, while we previously did sampling, don't sample. We really want everything now for this application here. And that goes a little bit into sort of the continuous profiling, and that sort of Robert name dropped as well. So yeah. I think we should give a round of applause to Abdi and to Robert for being here.